Chapter 50, solving equations with rational expressions. Think of an equation as a scale in equilibrium, okay? You can add the same number to both sides, this side and that side, and you can subtract the same quantity from one side if you also subtract from the other side. You can multiply everything on one side by the same number as you multiply the other side, or you can divide everything on one side of the equal sign by the same quantity on the other side of the equal sign, everything on the other side. As an example, suppose you wanted to solve 5 over x plus 3 plus 6 over x minus 3, which is equal to 80. You could multiply by the least common denominator, which is x plus 3 times x minus 3. You get rid of the fractions. You get the following. You distribute and so on. And after you distribute, you are left with x, which is equal to 7. We need to verify that this does not make the denominator 0. Otherwise, this is not a solution. If x is 7, this is okay, this is okay, this is okay. So x is 7 is a solution. Example 2. Again, multiply both sides by the least common denominator. There's only one denominator, so x minus 4, which gives you this quantity. You distribute. You get 4x, which is 3x minus 12 plus 16, or x, which is 4. Again, make sure the denominator is not 0. Oh. The denominator is 0. This is not a solution. This problem does not have a solution. Too bad. Example 3. Again, multiply both sides by x minus 4. Distribute, collect like terms. You get 0x, which is equal to 4, which is a false statement. This false statement cannot be made correct, so there's no solution. No matter what you plug in for x, it does not modify the left side being different from the right side. No solution again. And I do the following. I have a 3 and a 12 here. I crank it through like I did before. 0x equals 0, or something equals the same something. No matter what you replace x by, this true statement cannot be made false. So there are infinitely many solutions. And then we have a car and a truck leave a park at the same time. The speed of the car is 20 miles per hour more than that of the truck. The truck's destination is 210 miles. The car's destination is 186 miles. The car reaches its destination in 2 hours less than the truck. What is the speed of the truck? Well, we know the answer. The speed of the truck is 20 miles per hour. The speed of the car is 20 miles per hour more. This is a rate, time, distance problem. Rate times time, miles per hour times hours leaves you with miles. So let x be the speed, whoops, that should be a 20 here. Let x be the speed of the truck. X plus 20 is the speed of the car. The distance traveled are respectively 210 and 186 miles. We're interested in time. Divide both sides by r and you get t, which is distance over rate. So the distance of the truck is, the time of the truck is the time, the time of the car is the time of the truck plus 2. Now, was it 2 or was it 20? The car traveling distance in 2 hours less. That part is 2. Okay. So there's a 2 here. You plug in distance over rate, distance over rate. The two are equal if you have a 2 on this side. You multiply by the least common denominator. You collect like terms. You subtract and so on. You get a nice quadratic, which you can solve by, right now, if we can't factor, we don't know any other trick. We have not had a quadratic formula yet. Relax, you'll get it soon. So can I factor the left side? My product sum method gives me the magic numbers, which are negative 42 and 50. Okay, that's the sum you want. If the sum is 8 and the product is negative 2,100. So you know how to split up the 8, these two terms. You factor out, you have greatest common factor. Two solutions, x is negative 50. Reject, the rate is not negative. And x is 42.